Well, hi and welcome, and thanks for joining me here in my shop. Today I'm going to be starting on this Viking radio, and I'm going to check it out and see what kind of condition it's in and what I can do to improve its operation and its look. Basic AM radio. So sometimes I like to plug these guys in right away, but often I like to make a little bit of an inspection before doing that. So why don't we just take a look at the outside of it first of all. Nice radio, and that's got both its knobs. Geez, are these the originals? This one has a white pointer mark on it, yet it's for the tuning. You can see the pointer moving in there. This is probably not the original knob. Matches this, they're probably not original. Nice label there, Viking. This is metal. You can probably clean this up somewhat, or it could be easily repainted. You could easily repaint something like that. So the wood cabinet's not so hot on the top here, so it's really looking for a refinishing job. But it's a simple square cornered cabinet. It means it's very easy to refinish. No curves to worry too much about, except down in here. Probably pop this off with a bit of luck, maybe not. So it's up for restoration. What does it say on the back here? So here's the tube lineup: 12 BA, BE, another BA. Oh my gosh, a 12 AT6, 35 C5, and a 35 W5. So the fact that it's got this 12 BA6 out front means this should actually be a fairly well performing radio. See, it also says phono input. Where it must be on the cabinet here somewhere. Now I can see little bits of the antenna here just poking through, so I know there's an antenna on the back of this, on the back of the back. Serial number, really easy to find. Model number 54-51. Volt amps 30, so about 30 watts. Licensed by Canadian Radio Patents Limited, patented 1937-1954. So this is a 1950s radio, I would have to guess. Nice rubbery cord, kind of a crazy long cord here, but very, very good condition. Don't know about this so much. I might have to take this apart even and take a look at it. The conductors are separated here. Well, I can plug this in safely. Even if there's a dead short inside here, I've got a way of doing this. It won't cause Niagara Falls to run backwards. Let's take this. So the back, so I can see rivets here and here. So this cardboard back is probably riveted onto the radio. So the radio is probably held in with screws underneath. The radio is not held in. Oh my gosh. Is anything holding this in? So you can see there's the screw fitting right there. And you can see the hole in the cabinet where it's supposed to be. How you like that, eh? There it comes. Okay, take a look at the cabinet here inside. Any surprises in there? Can you read that? What it says there? It says cabinet shipping tag right here. And it looks like a perforated page, so I can imagine there was probably a tag coming down. And I'm going to take a wild guess that this cabinet was being made by one company and the radio guts are being made by another. Oh, there's a note there. And so when the cabinet, maybe these feet are a little shot, this plastic is gone, it's just the metal foot left there. When the cabinet arrived, the company probably ripped off this tag and then put it into their paperwork to keep track of things. because quite often the cabinets are not being made by the radio manufacturers. Okay, well, we don't need to look at that anymore. Set it aside. So a couple things about this radio give it pretty good potential. What's that? There's a wire sticking out suddenly. Pretty good potential because of that extra front end too. Here's another indication. This is just an AM radio, and you can see it's got a 3-section capacitor on it. So another indication that this is actually a higher performance radio than you might imagine. All the tubes are in. The light bulb's in the right place. Looks like nobody's monkeyed with it. What is this thing though? We will find out in a moment. There's the tuning. Single string doing everything. And it's a little hard to tune, but a little bit of lubrication should help. Let's look underneath. Of course, there's no power transformer in this radio. Up we go. And that was just screaming out, all original. All original. Is there any single part that's been changed, especially this? That looks kind of new. And there's something down here that doesn't look to be in good shape. I'll have to take a closer look at it. It's got a lot of wax capacitors that appear to be in very good shape. Really good shape. Look at these ones. I've never seen these two here. Look at the way they're coated in wax. Can you see that? Hey, maybe it's time for the close-up camera. Let's get that going. Okay, we'll start in the bottom area here, down here where I got a glimpse of a curious thing here, and I'm gonna just bear with me for a minute. I'm going to set the I'm going to fix the focus on this camera here, so automatic focus is on, but that's really no good for the work I'm doing. If we leave the automatic focus on, it'll focus on all kinds of stuff that I'm not interested in. So I think that's pretty good there. Okay. Now we're on fixed focus. And what is that thing? Made in Canada. Looks like a capacitor. What does that say? Oh, it's 1.54. Kind of looks like an outer shell is shattered on it a little bit. Okay, well, I think that's just a capacitor. I don't think it's anything too spectacular. Go over this way. The capacitor, it's quite interesting. It has like a tag. I've never seen it done like this. It has a paper tag as if it's been laid across the capacitor and then waxed over. 0.033. Some manufacturer of capacitors, I guess I've just never seen it. And there's this one, which it just looks newer to me. Like it doesn't look. That says USA. Yeah, well, the parts could come from almost anywhere. 10. I don't know. Does that look resoldered down there? It does kind of look resoldered. That look like a wire cut going nowhere. It does look like a cut wire. And see how the strands are hanging out? That's not factory work. What cut wire? Well, let's see. There's what kind of capacitors in this radio here? We'll look for the original capacitor. Where is it? Oh, it's this one. What am I doing? It's this thing. Oh, look. Okay, so that's not original. I didn't do that in a factory. So this is a replacement. And I'll bet you it's only got 2 wires. Take it back, it's got 3 wires. And 1 black one up here. So it's got 3. Is it 3 on here? 40, 40, and a 20. 40, 40, and a 20. So that would be, the 2 main filter capacitors, and the 20 is for the bypass on the output tube. What's this one doing here? 10. Like an extra 10. It's pretty, it really looks like it's been added in. Well, added in. Jim, the old, well, I was going to say the old one's still here. No, this isn't the old one. This has also been replaced. So I don't know what's going on. Maybe the bypass requires more. We'll figure it out as we go. But anyway, that's the story. Looks like somebody's come in here, replaced the electrolytic capacitors, and this wasn't done recently. They didn't put this in recently. Anything else get changed out in here? Aerovox 0.047. Gonna look right up into the IF can. So that's the end of the screw shaft in the IF can. You see one of the IF terminals, the four of them, one of them's got green paint on it, marking. I want to mark one to mark them all. This one here too. What exactly it means, I don't know, but it means something. You can see how there's a little grounding strap in this kind of tube socket. It just goes over to a rivet. That's just a mechanical rivet. So if you're plugging tubes in and out of this radio every day you plug tubes in and out, sooner or later you're going to work that rivet loose. You should not be unplugging and replugging your tubes. What's going on with that? Resistor. So that looks like a solder spill from above, is what it kind of looks like. Maybe, I was going to say, maybe more parts have been changed here than I realized. Nice looking capacitors in here. I think we could probably start this guy up fairly safely and see what it does. Probably gonna hum. That would be my guess. It's pretty big. Crack right in the middle. Yeah, I can stick my fingernail right in that crack. So it's nicely waxed, but cracked. Cracked in the middle, and it's also roughed up. It looks like a piece of, it looks like maybe a solder iron strike or something there. Broke the wax seal. Very interesting. I just wonder how well this radio will work as it is. So here's the, this is probably the antenna coil. Could be the oscillator coil. Usually in a radio like this they'll put the oscillator coil underneath and stick the antenna coil up on top. Is there such a thing up here? No. There's no such thing. No coils up on top. Did I miss the other? Yeah, here's the other coil here. Okay, so one of these two is the oscillator, and one of these two is the antenna coil. We can probably figure it out pretty quick if we can just spot where the antenna wires go. So one of them goes here. And then you see that black wire going down? That's heading to the coil, I think. Coming out of the hole, it's going through this resistor, it's going, I don't know, okay, don't know, not that easy. It just might be interesting to note that this coil is oriented this way and the other coil is oriented 90 degrees to it, so they don't interact. And probably keeping them some distance apart too, as best they can in the radio. Okay, yeah, we can turn this guy on. Ooh. Wait a minute, what's that? What's this? So that's the lead wire. Look at it. What happened here? That's pretty weird looking. Again, not something you'd expect to see in the factory. So normally, a wire like this, you kind of see that it's actually two wires twisted. Normally the wires coming out of the coil are fixed to these terminals right on the coil. and then the radio manufacturer pops in the coil and solders to these terminals. He's probably the guy making the coil too. He's probably got a coil making bench and somebody's spending their day making these coils. So they don't want to do this kind of thing. This airborne solder job is not, certainly not what happens in the factory. And there's a blob of solder down below. So there's a history here. Something has gone on. It's possible somebody, it's really not. I was going to say somebody cut this for test purposes. Sometimes, in the old days, you can cut wires and make assumptions. Let's just track the wire. Comes up the back and right there. I don't know what to make of that. I don't think it's quite normal. Is there anything funny about this coil? Does it in any way look like it's not the original? So I look at the solder job and try to judge whether this is something that would be done in a factory or not. It looks like a factory type thing to me. And that, this is fitting in perfectly and everything looks, so I think it's probably original. I don't know what that is. I don't know. Okay. It's there. Good show. Well, I think it's time to put on my helmet and turn this guy on. Oh, what was this? So this is the security wire. This is the security wire. I'll show you how that works. Have you ever seen a security wire? Oh, I see what it is. It's not. I was going to make a joke there, but the joke's not going to work. Because I saw it was tied here, but I didn't see that somebody had brought it up to here. So somebody's cheating a second speaker, and they had a soldering iron. Whoever did it had a soldering iron. We're going to undo it. Sure, this guy, he connect to the right thing? I'm not sure. Get that off there. She's a dusty, pretty dusty radio. We're going to leave it dusty for now. Okay, having done essentially nothing to this radio, what will happen? Now, if you're a new viewer or you haven't viewed many of my videos, I do have ways of doing things in my shop to keep myself safe and to prevent explosions, basically. Or high power short circuits and stuff like that. One of the things I do is I use a very simple system called a dim bulb system. System is way too strong a word for it. It's a dim bulb. It's a light bulb, a incandescent light bulb in series with the radio. So any power reaching the radio from the outlet gets there through this light bulb, depending upon how I have my little switches thrown here. So this is off at the moment. This is the main power here. If I flip this switch down, you hear the sound. Power would be going through this light. It would go through this one too, except I don't have this screwed in tight. This is out right now because I have a small radio. Just need one light bulb here. And so when I hit the power and I turn the radio on, if the radio has a serious short circuit in it or something like that, all that will happen is this light will come on bright. It won't blow my circuit breaker or anything like that in my house. It won't do anything bad. And I'll know because the light is blasting in my eyes. I mean, it'll be pretty obvious. With a radio like this working okay, what should happen is I turn the power on. There's a bit of a rush into the cold heaters. So the light will go whoosh like this and then dim down fairly quickly. And then it'll sit there for a while the heaters are heating up. Now once the heaters get hot enough and the rectifier tube is producing high voltage, more current will flow through these tubes, and that current draw will make the light come a little bit brighter. So it looks like bright, dull, and then it'll get brighter as the sound comes out the speaker, if everything's working. You'll probably notice a lot of dial lights have exactly the same behavior. I'm not sure you can kind of use that exactly the same, but you'll notice that a lot of dial lights, when you turn them on, they go through the same sort of process for slightly different reasons. Okay, enough talk about the light coming on. I can't delay any longer. Let's switch this off. Okay, so I'm going to put the power on here. So in the outlet right now, you'll see 122 volts available. And that's because no current's flowing and there's no voltage drop on this light bulb. As soon as I turn the radio on and current begins to flow, some voltage will appear here, and this will drop. And I'll put this in sight here. You can see it. Kind of see it. I don't want to hold it. I want to be able to run. I want to be. There. Okay, that's good enough. Okay, here we go. Da, 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 da. Okay, so it came on, but not very bright at all. Now it's dulled right down. We're at 109, 111, so it's coming up. Should go back down. 15. 115 volts. Here it comes. 113, 112. She's a hummer. Humma, 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 humma. Okay, so that's actually a really, really good test of this radio. First of all, the tubes, all the heaters are good, or this radio wouldn't have come on at all. Must be producing some high voltage, or you wouldn't. I think you wouldn't have heard anything out of the speaker at all. Something that proves some of the tubes got to be in good shape. They're probably all in good shape. Is probably the state of affairs. You know, the speaker's okay. Everything. That's a really good test. The hum is nothing to be too upset about. We will knock that out with some new capacitors. So kill the power here. So typically, let me put the heavier side down here. Typically in a radio like this, at this age, the original filter capacitor is not going to be any good. Now, this is a replacement one, I believe, and it's also not any good. So we're going to replace that. This is probably good, and that probably doesn't need to be replaced, just by looking at it, but don't know for sure. Well, why don't we do it? Let's do it. Let's do it. I'm in here today because the weather has taken a turn for the worse outside. Now, I'm going to think a little bit. I'm going to be putting in some small black capacitors. Where's that yellow wire go down here? It does go somewhere. Oh my gosh. Okay, let's take a look at the close-up camera. So that's a little bit surprising. Okay. Just saw. So we follow the yellow wire. It's on that terminal there. Watch when I push it. A good deal of it never got soldered onto there, and you got strands hanging out. Ooh, ooh, ooh. It's another indication that this yellow is replaced. I don't think there's any doubt about it, and I'll bet you this is also, because it just looks too new. 85 degree component. You know, we might be better getting higher temperature components. There's that cut wire. So that, now wait a minute. So my guess was that cut wire went to the original capacitor. But look what he's done here. He's got a red wire and the yellow wire coming to the same terminal. And what red wire is that? Okay, it's not coming to, it's leaving from. Okay, so that's the red wire carrying B plus into the radio. So he's got the yellow one coming out of here. Oh my gosh, that's not good at all. He's got the yellow one coming out of here, going to where a red wire is. Well, what? That's a boob up, I think. Now let's follow the red ones. This red one is working its way all the way to here. And I see a fairly large high wattage resistor right there. It looks like red, brown. Looks like 220. You also see on the terminal right dead center of the screen, you can see the remnants of a red wire that was cut there. And you can see the new red wire. We can trace it back to the capacitor. So that red wire is good. This one. So what he's done here is he's brought the red wire here when the yellow one should have come here, and he's put the yellow one here. And the problem with that, and it's a significant problem, is the yellow one is going to have less capacitance, 20, well I've already revealed the secret, 20, when the radio is looking for at least 40, maybe more. We don't really know what originally was in here, but probably 40. But the thing about the 20 is that it's only good for 25 volts. So he's got the 25 volt part of this capacitor apparently hooked up to where there's going to be like 110 volts. 110, 25, that doesn't sound good to me. So that's a mistake. Now is that what's causing the hum? Pretty interesting question. There's something else a little odd there. So where the red wire comes to that terminal, there's a bare wire on it. There's a bare uninsulated wire right center of the screen there. A little dab of solder on it, like a solder strike. Goes over to the terminal. Looks factory. But wait a minute. That's hooked up to B+. I don't normally run bare wires on B+. They normally run red insulated wires, and the bare ones are usually used for ground connections, or ground connections to the chassis, or things that just have no potential relative to B-. Even the B- in some radios with bare wire. I'm trying to find a bare wire here too. I won't find any, except that one. Well, there's a little short one there, but that's a different story. One bare wire in here? That's an awfully sloppy looking solder up thing there too. And in fact down here also. Been more work done in here than I realized at first. I think. Well, so what should we say? Should we say, hey, this is probably good? Switch those leads and see what happens? No, it's not worth doing, because even though this might still be in good condition, maybe this is only 30 years old. It won't be in good condition for all that long. It probably is not in good condition. It's easy and cheap to replace, so we'll replace that, make these corrections, and so he's been in here with a soldering iron, big blobs of solder. Oh, a floating connection here. Again, this is not a normal factory thing. They normally don't make a connection out like this. It happens, but... So are all these replacement capacitors? All these ones? And where's another one of those? Down here. I kind of doubt it. There's another one up here. So that terminal right there appears to have red paint on it. So it hasn't been resoldered since the red stuff got on there. On there. And does that look like red paint on there too? And some over here? No, can't. Why would they put red paint on stuff? Somebody's troubleshooting technique? They work their way through the radio dabbing red paint on things, or somewhere there. I have no idea what. Oh, you know what? Maybe it's the kind of solder they used left some kind of resin, and the resin is red. There's red everywhere here. Yeah, well, I'm not sure I can extract any meaning out of it. Okay, I think I got the story straight. Straight enough for me to take action. This guy comes out. We can remove him with some force here. Lots of space, working the new ones. I will install them, and then we will see what happens to this radio. So I'm looking at the usual problem here, and that is these little replacements, which are going to replace this thing, really need to be held in here in the radio somehow. Of course, this was held in with this big strap. These aren't terribly heavy, but I'm going to be probably connecting them just to these wires. I'm going to cut the wires, and I can do that right now, in fact. Preserve the wires to begin with, even though one of them, or two of them rather, are going to the wrong place. So, you know, I could potentially connect to the end of these wires. So some of these are a little bit short. And I'm still not sure what this one's doing in there. What is it in there for? Well, we're probably going to have to consult with the schematic. In fact, you know, it might be wise to do that right now. In case the fellow who did this did something, they've already found one thing he's done. That's mixed up the two lead wires from the capacitor. We should probably take a look and try to identify this. So I think maybe that's the next step, actually, is to get a look at the schematic for this radio, the Viking 5451. Okay, it wasn't too hard to find this. That's the model 5451. Let's just take a closer look at it. Let's look at the overall, actually, the overall deal here. What's this note? All voltages plus minus 10% measured to B minus with a 20,000 ohm per volt meter. So they're using a fairly good meter, measuring things to B minus, not to the chassis. So we'll be looking for that situation. In fact, look, it's right here. I think I've already spotted it. So here we see a fairly large resistor here, 330K resistance, and a capacitor. It's probably a point. Well, it doesn't actually, what's that? T1. Okay, don't know. T, tubular. Tubular 0.1 is what that is. So there's a 0.1 capacitor here. That's the chassis, and this is the B minus line here. See, the only connection to the chassis will be there, and then up around the antenna. Might be one more in here. There's one there. So, as I've said many times, I don't quite understand what goes on with the radios in terms of this front end grounding, but this is how it works. I'll put the front end part to the chassis, but then the rest of the radio is tied to B minus. There's a voltage, 88 volts. Okay, let's keep looking at the schematic. No, don't get ahead of yourself here. Fashion loop consisting of several turns of wire. So this is during the alignment process. They're saying you should transmit the signal into the antenna of this radio. Going from there, component values. This is a nice schematic. They've taken time to write lots of details in here. All the codes they're using. It's just, I can't quite read this. I suppose you can't either. Let's make this bigger. Alignment and sensitivity. This is the alignment instructions here. Probably nothing unusual about it at all. Nominal sensitivity for 50 milliwatts output. That's interesting. So they're telling you what you got to put onto your signal generator output to achieve this in the speaker. It gives you some idea of whether the radio's operating with its proper strength or not. Because, you know, a weak radio is easily compensated for by just turning the volume up. And so it's not easy to know your radio is actually weak. So here's the tube lineup again. Same tubes. What's that? Oh, here's some change notes. Huh? 11, did I say 1100 volts? Condenser added. At, does that say at or and 1 M resistance. Hey, nobody ever signed off on that. Oh, here it's down here. Added was. I don't understand that. No. Let me read it again. 47. So they're describing the thing. The thing was added. I don't know what that means. Is that it's an ampersand done really poorly? Or is that's a spot? That's an A, a B, and a C. That's what that is. So it's a triangle with an A in it. Added B was to. I don't quite understand the English there. Could always look this guy up. OCB. We gotta find who's OCB. Obviously, this is coming from a big company. Do this kind of stuff on a schematic. There's the IF frequency, by the way. No surprise there. Okay, we're just learning the schematic here. So we're showing it. This is for a different radio. 5450. This is the 5451 here. Tuning range 540 to 1650. It doesn't go to 530, and it goes beyond 1600. Intermediate frequency, undistorted power output, maximum power consumption 25 watts. Okay, now we're going to look at the schematic here. So all the tubes in series, and here's the tap off to run the light bulb. Why aren't they really showing this as part of the circuit? Here it is here. It's up here. It's showing up here. Unless they're showing they're just showing the heater lines just coming out. And often they put little X's on it and then match them up down here. 3, 4, 4, 3. So those are the pin numbers. Notice they're actually describing the order of the pins. Is it the same every time? This one's 3, 4, and then it's 4, 3, 4, 3, 4, 3, 3, 4, 3, 4. Now, does that really mean anything? I don't know. Probably, maybe they tried this in one of their experiments in their design shop and discovered that it makes a small difference which way you turn these. I don't know. I don't know. Yeah, there's that. There's C. This gigantic. Oh, it's right across the power line. 1100 volt test. Here's another one. 1100 volt test. And this one. 600, 900 AC test. So these capacitors are in a peculiar position in the radio in that they're exposed either by their position in the radio, like this one, or because they're protruding out the back, or you can get contact with them or something. You have a big concern that a huge AC voltage is going to go across these capacitors. I think that's just oddly large. Like, are they trying to get ready for a lightning strike or something? I can't imagine that. 1100 volts is not much when it comes to lightning. So I don't know why it's such a high. Such a high. Same note. C. C. Hey, they didn't put a note here. Here's another note there. 1 meg. Well, and there's the other one right there. Again, it's going B plus. I don't know why it's so large. Something funny happened in this radio? It's a mystery to me. Normally capacitors are rated like 600 volts. Getting them higher than that is actually got to go out of your way to get something with this kind of rating on it. I don't know. Were they doing this because they wanted these capacitors to be good forever? So they bought overrated capacitors that would never deteriorate because there's a bit of a shock hazard. That's what I really should be saying. This one's a shock hazard on the outside of this connector, and shock hazard when you're fiddling around with the antenna. The shock hazard is you bring yourself into electrical contact with the B minus, and the B minus is actually at 120 volts because of the way this has been plugged into the outlet. The lamp is at 47. Oh, look at this. So this is a 50 microfarad. This is an 80, and I'm going to put in two 50s. Here's another one. Oh, so there's 3 of them. Okay. So this is starting to explain the three. What about up here? Isn't there a... oh, wait a minute. Okay, back up. I'm not finishing my thoughts, but that's okay. They're not worth finishing. Cathode. Here we are. Cathode resistor. 220. There it is. The 220 I saw earlier. And there is the yellow capacitor that's in there. 25 volt capacitor. Then what's going on over here? Wait a minute. Wait a minute. So what I think maybe what's happened here is the original 3-part tubular, big tubular capacitor had 3 50s on it, or maybe two 50s and an 80. It may have even had 4 sections. It may have had 2 50s, an 80, and then a 10 25 volt one. It may have had 4 wires coming out of it. When the guy replaced it, he replaced it with a 3-wire one, which is 2 40s, probably aiming for these two. And what did he try to do with this? He would have tried to put at least the biggest, at least one of the 40s. So, well, okay, so so this is a 40, let's say, and this is a 40, and then this would have to be, what's he left with? Well, he's left with the 20, which he had hooked up incorrectly, and a 10. Well, the 10 must be this. We'll sort. No, it wasn't, was it? Was it? Can't remember all my observations. No, it wasn't. It wasn't. This 10 is hooked up. Oh, you know what? This 10 is hooked up where one of these should be. Oh my gosh, what's he done? He's taken 3 high voltage capacitors and 1 low voltage, and he's installed 2 high voltage capacitors and 2 low voltage one, and that's really the root of the problem here. What's this one? Another one. Wait a minute. E20. Now there's no parts list, so we gotta depend on this. 150 volt E20. It's between the B minus and the B plus. Now you can see it right here, B minus and B plus. 105 volts there, 88 on the other side of this resistor. How much on the plate here? Did they write it anywhere? They did not write. 105 volts. 105 volts should be on this plate. 105 there and 88 everywhere else in the radio. Did they write them up near here? Yeah, 84 there, 84 there. And 78 over here. What I'm doing is I'm getting familiar with what's available in this schematic. Interstage coil. Do you call that a transformer? Gang shorted at maximum capacity for phono operation. Gang shorted at maximum capacity. Really? So there are radios with phono input. Where's the phono input on this radio? There's no phono input on this radio. That must. Oh yes, there is. Yes, there is. Yes, there is. Yes, there is. Yeah, well, right there, Jim. You're just talking about it a second ago. So you can see the phono input goes right onto the volume control slider. In some radios, when you operate the phono, the radio is still connected and going. And you have to either detune the radio, like tune to a quiet spot, or sometimes I think when you attach the cartridge and you plug in the turntable here, you're changing the impedance enough that it drains out the signal from the radio. I'm not sure. It's kind of clumsy how they do this though. Some of them, you push the phono jack in, the pin on the phono plug you're pushing in actually operates a switch inside this, but that's not the case in this one. No, I'm looking at it. No switch. So you have to do this. You have to tune the radio maximum capacity. I wonder if it shows on the front of the radio at all. I'm gonna look. I'm just too curious. Where's the cabinet? Does it say phono or something right at one end? Doesn't say anything. But I do notice on the cabinet two tick marks indicating the alignment, the pointer alignment tick marks. So I noticed that too. Now let's go over here. So this one they've written 10% at 56 ohms. So this is a critical one. They wouldn't write the 10% if it wasn't critical. High impedance loop. Why would they bother saying high impedance loop? Why didn't they just say loop? I don't know. I didn't hear the answer, so we're going to carry on. Okay, let's just run through how this radio works. So power supply is producing the B plus pressure between these two lines. They're going to drive the electrons through the tubes. Signal's coming in the antenna. The antenna is essentially connected directly. We'll see what they've done here. See how they've heavied up this line? And then they've heavied up this line, the draftsman. And he's heavied up this and heavied up that. He's showing the signal as it passes through the radio. He's showing where it's going. Okay, he kind of cheated his way around here a little bit. Oh, no, he didn't. Comes down through here. Signals, no, he did it. Yep, right through here, out through there, and on its way. Huh. Okay, Mr. Draftsman. This is a very nicely drawn schematic, by the way, in my humble opinion. Okay, so the signal is brought in onto the grid of this tube. This tube is probably AVC controlled. The AVC will be on this line here. Sure, AVC controlled through there. So the gain of this tube is controlled. We're tuning this coil against this capacitor, and we're then tuning this coil against this capacitor, and we're tuning the oscillator coil against this capacitor, each one of them with a trimmer. Okay. So here is a 330 ohm cathode resistor with a bypass. So there's a cathode bias applied to this tube and also AVC bias. If you look at this one is, well, this guy could be playing a little bit of a cathode resistor role maybe, but I don't think so. Okay, so signal gets through here, gets transformed. This is a little unusual here because this is a center tapped, or sort of close to the center tapped coil. It's a little bit unusual. And the signal comes out onto grid 3. Grid 1 is carrying the local oscillator signal. Grids 2 and 4 are screen grids. And the suppressor at the top there. Okay, signal through here. Comes out the other side of the transformer. This is a 455 kilohertz signal now. Gets boosted here. It's another cathode resistor and bypass. Of course, this is being done at RF frequency, so you don't need a big capacitor here to bypass it. And again, AVC is going to be applied here. I would think, yes. Oh, AVC applied before the 1 million. So the 1 million here is providing a fair bit of isolation between what's over here and what's over here. The AVC line is an easy way to sneak signals back through the radio and have them show up at the front end where they're not supposed to be and then come racing through again, which would be feedback. There's special stuff going on here. Nope, out we come through the second IF transformer. Things get a little more complicated here. So here we see a diode. We see another diode over here. This one is just done away with. It's just grounded out. So it's not doing a thing. So it's a single diode detector here. It's rectifying the signal that's coming out of this transformer, and DC is building up in here. DC, the rectified DC would be available at the top of the volume control past this 50K. The DC is also sent off this way, going through a big isolating resistor, 2.2 megohms. There's almost no current flow in this circuit, or really you can think of it as no current flow, and so there's no voltage drop on these things. So whatever voltage is developed here is what's going to be pushed through, more or less, right to the grids. And what are we talking about? We're talking about just a 5, 10, 15 volts, something like that, DC. Meanwhile, the audio is sitting in here too. So the DC is ripped off here and sent on its way to fool around with the front end of the radio. The DC part, the AC, carries on all the way through here, all the way down to B minus. So the audio signal is dropping across all this resistance. Now this thing here is some tone adjusting control. This is a terminal, a tab on here, like a fixed tab. It's some kind of like a loudness thing where when you turn the radio down, the treble and bass stay up a little bit. Something like that's going on, of some sort. It's just an attempt to improve the sounds of the radio at low volumes. I think that's the best way to put it. Audio carries on. At this point, the DC that was generated up here can't go any further. It's stuck on this capacitor, and it's not going anywhere here either. But it's interesting to note that through these resistors, DC can get all the way to the phono jack. But they've got this capacitor here, so you can't complete a DC circuit through the phono jack. Well, that's kind of interesting, because you could measure it. You can measure it at the phono jack. Kind of a dumb place to measure it, though. It'd be much better if you want to try to measure it right here. Okay, audio is coming out now. DC left behind. Big 10 meg grid resistor here. Signal gets on the grid. This is a two job tube, two tubes in one. A diode tube, or rectifier, and also, or a detector if you want to call it that, and a amplifier. They actually have nothing to do with each other. They just happen to be sharing one glass tube. Okay, and audio then is boosted enough now to drive the output tube. And over it comes this very critical capacitor here, because there's a pretty high B plus here. This guy's leaky at all. Some of the DC B plus will end up on the grid, causing the 35C5 to be very, very unhappy about that. This guy's working hard. He's got the highest B plus. He's really pumping it out. He's also got power in the heater, you see, because he's a 35C5. You got 35 volts on the heater with the same current as all of them. They're all carrying the same heater current, but with the extra voltage here, he develops more wattage, more power to spit the electrons into the tube so they can find their way to the plate en masse. The massive flow of happy electrons comes down through this coil here. Unfortunately, this guy's hanging on a little bit, so he starts jumping up and down too, and next thing you know, the speaker's jumping in and out, and we can hear it. Fantastic. That's a kind of a weird explanation at the end there, but it's a long journey through this little radio. Is there anything else here that I have overlooked that I really should? Thank you, Tom Seeker, for downloading this, or uploading this rather. No, I think I've seen the whole deal. Got the whole deal. It's a pretty straightforward radio. Nothing too unusual going on in it. Great. Okay, back to doing those capacitors. Okay, let's see if we can find some of these interesting things in this radio. Capacitor connected to the chassis. So that's a fairly large capacitor, and I see it already. It's this one up here. I'm recognizing it. You can see there's a resistor right here. Oh, let's try the other camera. make it a little easier. So what caught my eye was that resistor sitting up against that capacitor. That's a hint that somebody put those together first and then stuck them in the radio, and almost certainly this end is going to the chassis. Where is it going? Wait a minute. Yeah, so now that's the resistor, and then it's, there it is, right down to the chassis there. Okay, so this is one of their 1,000,000 volt capacitors. It looks a little juicy on the top there. So that's kind of a safety issue, that one. That's why it's worth spotting. If you notice something else too, maybe you caught it on these two screws and washers are what are locking down the tuning capacitor up here. And you can see that they're washered. And you can't see it, but those bolts or screws going through there, they won't be touching the chassis either. When you come up on top, it's going to be a little hard to see. There's the rubber you can see down there. So this is not connected to the chassis, and I had gotten a doozy of a shock off one of these radios one day, long time ago, by not realizing what's going on and touching the metal frame of the capacitor here and the chassis at the same time. And probably part of the formula for that was having the unpolarized plug plugged in just the right way to give me a shock. I got quite a lift. It really surprised me. I've never forgotten. Now, every shock is a warning, is a big warning. You should not get even the mildest shock and say to yourself, "Oh, there's nothing." You should stop and think hard about how did you manage to expose yourself to getting a shock. I mean, it's a perpetual danger in here doing this kind of work. You know, rather egregious solder job there. Okay, so if we take a look at the volume control here. So the center terminal in there is carrying the audio away from the volume control. It's going through this resistor and like the other way around. Okay, so the sound coming from here, from the phono, gets onto the audio system on that pin. Now there's got to be another wire going from that pin. What a schmozzle in there too. Is there a cut wire there? I see a black, I see what looks like a black cut wire. Okay, not to worry about it. So the two outside terminals you can now see on the volume control. One of them is going to be, I don't want to say grounded. It's going to work its way back to B minus. I don't think it's that one. Let's follow the other one. Oh yeah, what's this capacitor here? So this capacitor and the floating resistor, and they go around to another terminal on the volume control. You can't quite see it. That's that loudness control or tone adjuster when the volume's low. I believe. So that would be on the I think that's the grounded terminal. Well, it can be grounded. It's got, well, if it is a grounded terminal, it's not grounded very well. I don't see any. Well, that's where that cut black wire is. Wait a minute, there is another black wire coming from there, right to there, right to the back of the volume control, back of the on-off switch here, which is a big. I want to say 0 point. I guess I could say that. That's probably B minus right there. And these black wires are probably. It's going up to the capacitor. The capacitor I cut out. And then there's another black one going down, and that's going into the radio. What's going into that knotted? No, it's, yeah, nope, yeah, nope, it's going by. I don't know. What's going on under that resistor there? What are those knotted wires? Well, that would be probably going up to the light or something, wouldn't it? Knotted wires. Where are these? So here's the light. So they should be heading for the rectifier tube. Well, they're going into a transformer. No. Red and black. Red and black. What? Goes to the light. It must be seeing things. Must be going through a hole right. Yeah, you see, it's just dropping through a hole right there. And that's the hole. That's the hole I was looking at. So those are the lights. So that's the light hooked up to the boy. Taking a while to figure that out. That's a light. Well, you can see the black wire and the red wire coming out of that knot. Now the other black wire I was tracing off the back of the switch, I think it looked like a shiny black one. It doesn't look cloth covered. Okay, let me get in there and wiggle it. Oh yeah, there it is up there. So that's the black wire that's conveying the B minus. Goes onto that terminal. Look, there's another black wire cut off it there. And this is the one. Oh, wait a minute. Not going there, it's going past there. Yeah. Why is there a black wire on there? Okay, carries on, goes up here, makes it all the way to this terminal. A couple of resistors and the black wire carries on. So that's like the B minus bus working its way through the radio. I think I'm following it all the way up to here. And it's a bunch more black wires hooked up to it. Come on, get it focused. And the black wire goes over here. Oop. Kind of sneaking around to this terminal high on the coil here. Okay, that's enough black wire tracing. Yeah, I was talking about the capacitor here. I stopped short of saying, look, there's a terminal here. This terminal is really connected to the metal frame of the tuning capacitor, but not to the chassis. And it's just something I just don't understand yet. Sooner or later, I will learn what that is. Please don't leave a comment on the video. Well, go ahead. You can leave a comment on the video if you know exactly what's going on here for other people to look at. But I probably won't see it, frankly, if you put a comment on the video. Okay. So I got that guy I should deal with. But really, it's just a matter of putting in how many? Four capacitors, but I probably don't have to replace this one still. And did we ever sort out where that one's really going? So it's going on to pin something. So I'm looking at the tube socket, trying to spot where the where pin 1 is, basically. Now, who put that capacitor there, for crying out loud? Can't they design these radios better? So there it is. There, I see am I looking at the right tube now? So there's where pin 1 is. You can see the missing pin. Okay, it's easier to see looking at it directly with my eyeballs. But What was I can't remember what I was doing. What was I doing? Why did I even want to look at that? Yeah, it's getting a little long in here in the shop this morning. So I'm going to sort all this out myself, because I think I'm going to go around the bend here a couple of times. If I keep the video rolling, it doesn't help me while I'm doing this. Sort it out, get those capacitors in there, and we'll go from there. I think I'm ready. Okay, well, sometimes these don't go that well. This one seems to have gone really well, and what I'm really referring to is when you put the new capacitors in, sometimes there's no way to stabilize them in the radio. So in this case, there was a little tab sticking out here, and I was able to hook them up to it or attach them to it. So they're solid. So the negative, let's go over this and make sure I got it right. The negative wire is coming out. No shorts. It's going down to this terminal on the back of the switch, which is correct. And then we've got 3 large capacitor positives, if you like. One going down here. One going. These are the other guy's red wires here. That's good. And then the last large capacitor is hooked up to this terminal here. A little hard to see, I'm sure. Oh, I'm looking in the wrong camera here. So anyway, checking them over. This guy, I decided he's okay. He's in the right place to do the bypass thing on the output tube. So we're going to leave him on the assumption that, look, he's nice looking. He's suggesting to me he's in good shape. So we're going to find out. Now, if it's not in good shape, if this capacitor had no capacity, which is extremely unlikely, it wouldn't do its job of bypassing the cathode resistor. And the result of that would be a little loss of volume, and not much more than that, I think. You're not going to get the volume out of the radio that it has the potential for. Okay. Let's turn this guy on now. This time we may actually get actual radio operation out of it. We'll see. It still has all the rest of the bad capacitors there. Okay, switch off. Switch is off. Power's on with the dim bulb switched in. Just checking 122.1 volts today from Niagara Falls coming here. Actually I get the power here in Aurelia comes from a waterfall or hydro system about 15 miles north of here, and I think that's a 5 megawatt station. I think it's not very big, and otherwise we get it from a big nuclear power plant called Bruce Nuclear, or we might get it from Pickering Nuclear Power Plant, or it might come from Darlington Nuclear Power Plant. There's 3 large nuclear power stations in Ontario. So the bulk of our power is nuclear and hydro and a little bit of gas getting burned here and there. 0 coal. There's no coal in Ontario, so coal never was an attractive product here. Okay, enough of that. Let's see if there's enough water going over the falls to push some electricity through this radio. There we go. I gotta keep your eye on the light, because I did a bunch of capacitor work, and believe it or not, I get it wrong about 50% of the time. Believe it. And so I'm quite anxious to watch that. That was my soldering iron, which is gone now. Here we go. Did he do it right? Oh, looks good. Did you see? I think you can barely see the glow come up. That's a good sign. Turn up the volume. Do we hear a hum? 115 with the light bulb in, so there's a couple volts dropping on that. No hum. No radio. Okay, next step, tune it. Okay, next problems are showing up. Now that's either plates here rubbing on the capacitor, or it could even be from the, believe it or not, where the metal knob goes into the chassis, because I'm holding on to it. And this is an intermittent connection, so it's a little bit like doing this. Let's see if this does it. So finger on the thing. No, it doesn't do anything. So it's not coming from here. What else could it be? It's got to be rubbing capacitor plates. Let's just take a look at it. Let's like to take a peek at things initially. So I'm looking down these plates. I see this one is bent out and this one is bent out slightly, and that's almost certainly done in the factory under a careful control. That's not a mistake. Sometimes people reach into these radios. This one's not very likely because of this is mounted here. But other times people reach in and they'll bang into this capacitor with their hand. They don't know what they're doing, and they'll push these plates and cause shorts. I don't think the short's in there, is it? We'll have to study it more closely. Sure seems like it, doesn't it? Another thing is the shaft here, which is rotating, needs to ground properly to the chassis, to the frame here. It does it with a spring deal, which is very hard to spot. In this radio, the spring is a bent metal. Can I call the plates right here? See the edge of it right there. So that is bent over, is springing out, pushing against this shaft, trying to ensure that as you turn the shaft, it maintains solidly grounded. Now that was a different sound. Now that was a click of a bad connection restoring itself. That sound. How much you want to bet it's a loose tube or a bad tube? Okay, so get your money on the table. I'm going to turn the volume down. We're going to start at the rectifier end, and did you see the light flashing? Okay, not 100% sure what to make of that. But of course the light is getting its power from the heater of the rectifier tube. Okay, output tube? Oh. That's not too good. Turn the volume down. Wow. You know, usually those sounds go away after a moment. So in my mind, what I'm doing when I do this is I'm causing the pins to move around in the socket, and they're just basically scraping each other clean. So it's getting a little bit better. Okay, what about this guy? Holy! Volume's right down. I can't do much about that. Cover your ears. Wow. Okay, so this is the worst radio I've ever encountered like this. They're all bad actors. Now the fact that you can hear this is the first tube in the radio and you can hear it, it kind of indicates the radio's working. Okay, we'll assume now all these tubes are making contact good enough. Ooh, wow. That guy might be a bit of a problem. Look at this. There's a plate mounted on the back of this radio. Right here. What do you think that's doing? So that plate is hiding, I believe, hiding this antenna from that tube. The tube, when it looks this way, electrically, all it can see is this plate, which is screwed down to the chassis. It can't see past it. So that's got to be stopping some kind of interference problem. My guess is, after they designed and built these radios, they then found this problem. And then they then solved it in this way, by putting this plate in. It's a guess. Still not hearing anything. This light is still going up and down. Shouldn't be. Oh, now that sounds more like a radio. Oh, yeah. Oop. Okay, I'll deal with that next. It's definitely working like a radio now. Okay, let's get rid of the scrapey sound. The reason is, if there's any contact difficulties in here, then the radio is going to be tuning all over the place and doing crazy stuff. So I'm going to pull out my magic elixir here, WD-40. There's better cleaners you can get. So first I'm going to go at the contact right in here, the one I was talking about, the spring contact. Sounds like that got it right there. Ooh, what was that? Is that the string breaking? What's happening? What's happening? Lots of weird sounds coming out of this. What's going on here? This is really tight to turn. It's getting tighter as I turn it. What's going on? This is dragging on my bench? I don't think so. I'm imagining it. Ooh, listen to those. Crow. No, it's definitely gets really hard to turn right in here. Well, maybe the string is getting doubled over itself here. Sometimes the strings lock up. I noticed in the string diagram they recommend wrapping this around 5 times around. That's the most I've ever seen. Okay, who is it? It's this tube here. Son of a gun. Okay, radio off, tube out. What's going on with that tube there? What's going on here, buddy? So my experience with tubes and their pins is that the pins really don't, like these kinds of tubes, the pins really don't get dirty. I think you can see a little bit of blue on them. But I can't imagine that's... Now these are lousy sockets that are used in this radio. They're cheap, and they have problems. I am going to WD-40 right down through here. No, you know what I'm going to do? I'm going to spray it on the tube here, so I don't have tons of it dripping in the radio. 12AV6. That's correct. That is correct, isn't it? 12AT6. It says 12AT. I got a 12AV. You know, we can guess. Yes, you can interchange them, but do they perform just as well as each other? I have to do a little research. Now this just seems crazy. Spraying lubricating oil on the pins of a tube. Yeah, seems crazy to me too, but one of my mentors years ago said he did this to everything. Let's see if that's any better. Radio on. Give that tube a wiggle. Amazing, isn't it? WD-40. Thumbs up on that. Okay, now, what happened over here now? It actually tried to receive something. If I dare to turn this ever tightening. Oh. So if the string doubles over on itself here, it can act in a manner that it will break. Doesn't look like it's doing that. And you see there's a wide bundle of string, if you like, 5 turns of string, and there's only a small area for that string to be in. So you can turn this shaft dozens of times to go back and forth. Well, maybe not dozens, but you're going to turn it many times around. The string is going to try to travel because of the way it's wound. It can't travel because of the divot here and the tension on the spool shape here and the tension on the string. So what it tries to do, it tries to climb up the wall here. But they don't make this sharp corner here. This is rounded down. It's like a round spool. So as the string tries to crawl up, instead the whole thing, all 5 turns, slide back. It's a tricky thing if you think about it. You want the string to slide, but you don't want the string to slide. So there's a lot of problems at times with this kind of arrangement. It's a little precarious. If the shaft here becomes a little bit rusty, then the sliding action won't happen because it starts gripping the string too much. And then the string will kind of crawl up to the top part of the shaft here. Now you're operating with a wider diameter shaft on the string. So as you begin to turn it, you're pulling a lot more string with the turn. Now all that's happening in here. Let's see. So it's come across. Now it's just coming up against. Yeah. So you see, it's trying to crawl right up out of there. And that ding, that sound, was the bundle of string shooting back at a millimeter or something like that. And then the tension that I was feeling, because the string was crawling up on the wider part of the shaft, is gone. So the solution there is to work this a lot. But we've gone to the wrong end of the band. Yow, yow, yow. So many noises. It's doing the same thing the other way. It's crawling the other way, and instead of sliding quietly, it's jumping. Would a new string help that out? It might. But I think the real deal is to get this polished up in here. And, okay, anywhere in here? Radio time? Come on. Somebody in here. Ooh. Aha! Something. Anyway, let's go a little further down. Now it said when you close this capacitor all the way, oh that's much better, close the capacitor all the way, it's supposed to short itself and take the radio out of the picture so you can play a record. Let's try it. No, it's still there. So in radios that do that, the capacitor usually has a bar across here. And literally when you close down the capacitor, the bar contacts the stator. No such thing in here. Now checking for any contacts, shorts. Pretty convincing earlier. No. No shorts, and the radio getting more and more sensitive, I think, as we come upscale. So an interesting question is, so I'm just about done for the day here. So an interesting question would be, why bother changing any more of those old capacitors under there? And the answer is the radio's performance doesn't seem to be too great, does it? And it could be because of those capacitors, or it needs an alignment. So what I like to do at this point in the process is align the radio, because if the alignment is out, I'll get the impression there's a fault in the radio and go hunting for it when there really isn't one. So now's the time to try to bring the alignment up. In the course of doing that, often you discover more and more problems that need to be fixed. And the first time through, the alignment is just kind of a preliminary thing anyway. And you see how these are sticking up here? Pretty easy to reach here and grab it and go like that. Somebody could have done that. Occasionally people try to tune these guys up. They're not sure what they're doing. They find out turning these makes it go louder and quieter. They don't realize there's another set underneath that needs to be adjusted. They don't really know what they're doing at all. And the end result is I have an out of alignment radio on my bench. But we don't know. We don't know. So that's it for today. Thanks a lot for watching. Tomorrow we'll do the alignment and work on whatever comes out of that. whatever should come out of that. So, thanks a lot for watching, and we'll see you. You'll see me. Actually, you never see me, do you?